Using Instant Run is as simple as pressing Run or Debug with the lightning bolt displayed, after making incremental changes since your last build and deploy. When something's simple and helpful, most people are satisfied with that. Hey Wayne.
Hey.
Here you go.
Ooh, what's that?
It's an automatic dog feeder. It makes it faster and easier to feed your pets.
Nice, nice.
But we're engineers. We're not normal people. Wayne?
Oh, hey, yeah, I think I understand the mechanism for this, and I think I know how it works now.
Huh. So, let's take a look under the hood of Instant Run and see how it actually works. I'm Redo Meyer, this is an Android Tooltime Deep Dive, and this is Instant Run. Instant Run minimizes the time taken to build and deploy incremental changes to your app when you run the debug variant of your project. Rather than doing a full build, stopping the app, reinstalling and then relaunching it, Instant Run tries to only deploy changes, avoid restarting or reinstalling the app, or even restarting the activity. There are three variations to Instant Run: a hot, warm, or cold swap. Understanding what does happen and why will help you take full advantage of Instant Run and to understand its limitations and how your code changes affect it. This is a very simplified look at the Android build process. Your manifest files are merged and packaged along with your app's resources into an APK. Similarly, the Java files are compiled into bytecode and then converted to DEX files that are also included in the APK. First, it adds bytecode instrumentation to your class files, so we can replace code on the fly when we update it later. And it adds a new app server class that will run within your debug app, and which the IDE will use to transmit code changes that will be applied at runtime. Gradle also modifies the application manifest to inject a new application class. This will proxy your own custom application class, if you're using one, and injects custom class loaders that allow us to apply the real-time code changes. From now on, when you hit run, Android Studio checks if there's an open socket to a server running within your app, and if so, uses that socket to confirm that there's an Instant Run enabled version of your app running in the foreground of that target device. It will then check the app's build ID to make sure it's the version it expects before sending any changes. While you're developing, Android Studio monitors which files have changed and, based on that, runs a custom Gradle task that creates a DEX file for only the changed classes. That new DEX file is picked up by Android Studio, which deploys it to the app server we injected into the running app. The app server uses the custom class loaders to load and apply the updated classes. But, of course, the old versions of those classes already exist in the running instance of your app, so Gradle has transformed the updated versions to override the pre-existing classes. The app server then uses the instrumentation that we injected into our original classes to delegate each method call to the new override classes that we've just loaded. From now on, each time the affected method gets called, anywhere within our app, the new modified version of the method will get called instead. If you set breakpoints or look at your stack trace, you'll actually see the override named classes methods called within your stack. Okay, so that takes care of our hot swap. So when do we need to warm swap? And what is a warm swap? A warm swap restarts the activity. When we do things like changing resources, the restart is needed to reload the affected resources. Right now, that means changing any resource results in all of them being repackaged and resent, but we're working on an incremental packager that will only package and deploy changed resources. That said, warm swap won't work for changes to resources that are referenced within the manifest, or changes to the manifest itself. That's because the values read from the manifest are determined when the APK is installed, so you need a reinstallation before those changes can be seen. So, changing the string resource used to define the app name or drawable representing the app icon aren't supported within Instant Run. So far, we've looked at warm swaps to update resources, and before that, hot swaps that override methods within your running app. But what about structural changes that can't be applied simply by calling a method again? Like adding, removing, or changing annotations, fields, static or instant method signatures, or changing parent classes or static initializers. These cases require an application restart, using, where possible, a cold swap. Cold swaps apply code changes by sending new DEX files that are small slices containing only the affected classes to the target device before restarting the app. As a result, cold swaps depend on an app loading multiple DEX files, so that requires ART, which is only guaranteed available on devices running Android 5.0 or API level 21 or higher. For target devices running API level 20 or lower, and possibly using the Dalvik runtime, Android Studio deploys a full APK. Instant Run tries to be clever, but it can't turn back time. If you make code changes that affect initializers that were run when the application was first started, you'll need to restart your app for the changes to take effect. To perform an incremental build and restart the app, click Rerun. If you want to stop everything and redeploy a clean build, select Run and then Clean and Rerun App. To stop the running app, perform a clean build and deploy a new APK to the target device. So, is knowing how it works enough for an engineer? Let's check in with Wayne.
I've replaced the mechanism with a Brillo board. I think I can make this thing internet enabled.
That's what I thought. In that spirit, let's look at ways you can tweak your use of Instant Run to get the absolute most out of it. Instant Run is controlled by Android Studio, so you need to start and restart your debug instance from the IDE. Don't start and restart your app from the device or emulator, or things will get out of whack really quickly. Let's start by improving those full build times by tweaking the resources allocated to DEX. You can edit your project's Gradle.properties file to increase the maximum heap size of the Gradle daemon to enable DEX in process. The default here is 1 gig, so set it to at least 2 and DEX in process will be enabled, allowing multiple DEX processes to run within a single VM that's also shared with Gradle and significantly increases build speeds. If you've increased the JavaMax heap size in your module level build.gradle file from the default of 1 gig, you'll need to increase the Gradle daemon's VM size accordingly. Thanks to support in ART for multiple DEX loading, you'll get the best performance of Instant Run by setting your MinSDK version to 21 or higher. If your app supports earlier platform versions, it may be worth creating a new product flavor that sets your MinSDK to 21 for your debugging cycles, so you can take full advantage of the enhanced Instant Run support. Also, remember that any changes to the manifest will necessitate a full build and deploy cycle. So, if your build process automatically updates any part of the app manifest, for example, automatically iterating version code or version name, consider disabling those automatic updates in your debug build variants. Instant Run currently only instruments the main process, so if your app uses multiple processes, hot and warm swaps on those other processes will degrade to cold swaps or full builds if you're targeting an API level less than 21. Remember that hot swapping doesn't reinitialize objects, rerun class initializers, or modify data that's already been saved or transferred. Anything that has already run and won't be rerun without the app restarting. It's not always possible for Android Studio to know when that happens, so remember to restart your activity or restart the app when you know your changes will require it. If you're on Windows, you may find that Windows Defender real-time protection is causing Instant Run slowdowns. You can get around that by adding your project folder to the list of Windows Defender exclusions. As of this recording, Instant Run doesn't support Jack, instrumentation tests, or deploying to multiple devices simultaneously. But Instant Run is constantly evolving, with the team exploring new techniques to maximize the number of cases that allow for a hot swap and minimizing the need for cold swaps or full deploy and install cycles. And you can always find the latest tips and tricks on optimizing Instant Run on the Android Studio documentation. You can also explore the cutting edge by subscribing to the Canary or Beta release channels. If you're having trouble with Instant Run or any Android Studio features, let us know on Twitter or Google+. I'm Raider Meyer, and this has been an Android Tooltime Instant Run Deep Dive.
Yeah!